Hello students, let us do our next topic of applied maths, that is types of relation, that is given in the syllabus. So let us discuss type of relations. So first of all, we will discuss relations on set A. Relations on set A, we will discuss relations on set A. Here R is subset of A cross A. That means your first set is A and second set is also A. First set is A and second set is also A. So that means if A is equal to 1, 2, 3, A cross A is equal to what? That is 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. This is A cross A. And suppose we are picking some elements of this A cross A, it will become relation R on set A. Suppose we are picking here 1, 1, R1 is equal to 1, 1, 1, 2, 2, 1, whatever it is, this all are subset of A cross A. So this is relations on set A. Why I have discussed this? Because we will discuss the types of relation and everything we will do on relation on set A. So first relations, types of relation we will discuss is a null relation. Type of relation number 1 is a null relation, null or empty or void relation. So void relation. As its sign, why null set is a relation? Why null set is a relation? Now question is, why phi is a relation? Why phi is a relation? Phi is a relation. Why? Because phi is subset of every set. We know that phi is subset of every set. A cross A is also a set. So phi is also subset of A cross A. That means phi is relation on set A. That implies phi is also subset of A cross A. That means phi is relation on set A. First of all, we have discussed that why phi is relations on set A. Now, what exactly is this? Let us define. A relation on set A is called empty or void relation if no elements of A is related to any element of A under R. No element of A is related to any elements of A under R. Let A is equal to 1, 2, 3, 5. And R is the set of all order pair AB such that A plus B should be greater than equal to 10. So this is a null relation. Why this null relation or empty relation? Because if you take A cross A, this is equal to how much? This is equal to 60 elements will come. 1, 1, 1, 2, 1, 3, 1, 5. Therefore 2, 1. I am not in all. And last is 5, 5. Let us do it 12. 5, 5. Now, are in this order pair, this will be altogether how many ordered pairs? 4 into 4, 16 ordered pair. Whether sum of two elements of any ordered pair is greater than or equal to 12? No. So, no ordered pair of A cross A is satisfying the criteria of relation. That means R is equal to 5. That implies R is equal to 5. That means it is not if you are pick any ordered pair of A cross A, no ordered pair is satisfying sum of first elements and second elements greater than or equal to 12. So this is regarding the null set. Now second is universal set. Universal relation. Second is universal relation, as the name itself says, universal. That means entire. So a relation R on set A is called universal relation. Universal relation if each, this is the keyword I am writing, if each element of set A is related to every element of set A under R. That means whatever the criteria R has given, each and every element of A cross A is fulfilling that conditions. That is, we will write R is equal to A cross A. Suppose A is equal to 1, 2, 3, 4, and R is the set of all ordered pair, set of A such that modulus of A minus B greater than or equal to 0. Modulus of A minus B greater than or equal to 0. So in this A, what we are getting, A cross A is equal to what? A cross A is equal to again 1, 1, 1, 2, 1, 3, 1, 4. It will like go in this way, 4, 1, 4, 2, 4, 3, 4, 4. We see that entire elements of A cross A, modulus of their difference of first element and second element is either 0 or greater than 0. That means each and every element satisfy the criteria of relation mentioned here. R is set of all ordered pair A, B such that modulus of A minus B greater than equal to 0. From where we will pick up the elements? We will pick up elements from A cross A. Entire elements is, suppose I am taking first element 1 minus 1, 0. It is fulfilling. 1 minus 2 minus 1, modulus is 1 greater than 0. Modulus of 1 minus 3, 2 greater than 0, fulfilling. Modulus of 1 minus 4, 3 greater than 0. Modulus of 4 minus 4, 0 greater than equal to 0. So entire elements of A cross A is fulfilling this criteria. So R equal to A cross A. This is our. Now let us do the third type relation, that is identity relation. That is also most important. Now identity relation. Here A, B belongs to A. We can write here A, B belongs to A. Now identity relation. Third is identity relation. A relation R on set A is called identity relation if each element of set A is related to itself only. This is the very key word of this anti-relation, that is related by IR, set of all order pair A comma A, such that A belongs to A and A belongs to A. A belongs to set A comma A. This is A belongs to A. This is IT relation. That means one element, that is suppose A is equal to 1, 2, 3. Then R1 is equal to what? That means R1 is equal to, that is IT relation. If we will form IT relation of this set. So A cross A will how many elements? A cross A will 9 elements. That is 1, 1, 1, 2, 1, 3. Then 2, 1, 2, 2, 2, 3. Then 3, 1, 3, 2, 3, 3. That is, we are picking which order pair in which one element is related to itself only. That means here, suppose we are finding R1 is equal to 1, 1, 2, 2, 3, 3. It is identity relation. This is identity relation because A has 1, 2, 3 elements. So identity relations will also only 3 elements. 1 will correspond to 1, 2 will correspond to 2, 3 will correspond to 3. It is like this. Suppose this is A and this is again A. So 1, 2, 3, 1, 2, 3. A will correspond to only 1, 2 will correspond to only 2, 3 will correspond to only 3. This is the identity relation. If another relation given R2 is equal to 1, 1, 2, 2. Is it identity relation? No. This is not a identity relation. Why? Because 3 belongs to A, but 3 do not belongs to R2. So this is not a identity relation. This is not a identity relation. So identity relation, what happens? That is, relation on set is called identity relation if each element of set A is related to itself only. This is the identity relation. Now next is reflexive relation, that is the extension of identity relation. Next we will do is reflexive relation. Number 4 is reflexive relation. Reflexive relation. That is, a relation R on set A is a relation R on set A is called reflexive if each element of set A is related to itself. Related to itself. Here it was related to itself only. Here it is related to itself. Let A is equal to, that is reflexive relation is set of all ordered pair AB, AA such that A belongs to A. This is R. This is reflexive relation. Structure is same, but there is some difference. Suppose A is equal to 1, 2, 3. I am taking this example only. Then reflexive relation R1 is reflexive relation. Why? Because 1, 1, 2, 2, 3, 3. That is minimum 3 elements is minimum. That is 1 will correspond to 1, 2 will correspond to 2, 3 will correspond to 3. Besides this, there may be another element of in R1 of A cross A. Because A cross A, what we do in the relation, we are simply picking the elements of A cross A. We are simply picking the elements of A cross A because relation is subset of A cross A. Because what we are doing, we are doing relations on set A. So 1, 2, 2, 3, 3. Besides this, we can take 1, 3 also we can take. This is our choice. This is a reflexive relation. This is a reflexive relation. So for reflexive relation, what is the minimum number of elements needed? Minimum number of elements is that suppose there are three elements in set A. So for forming the reflexive relation, there should be each element will correspond to itself. That is, each element is seeing his reflection on the mirror. That is 1, 1, 2, 2, 3, 3. Besides this, there may be some another elements of the ordered pair A cross A. So this is a reflexive relation. Now suppose example. Suppose L is set of all lines in a plane. All lines in a plane. All lines in a plane, and a relation two line is establishing relation between them under this criteria when L1 parallel to L2. Is this a reflexive relation? Two lines L1 and L2 are maintaining relationship between them under this criteria that L1 is parallel to L2. Is it a reflexive relation? Yes, this is a reflexive relation because every line is parallel to itself. Then we can say under this condition, we can say that L1 and L1 belongs to R. We can say why? Because every line is parallel to itself. Every line is parallel to itself. So this is most of the important concept of a reflexive relation. So what we can say that what is the difference between reflexive relation and identity relation? Identity relation is subset of identity relation. Identity relation is subset of reflexive relation. Reflexive relation. That means all identity relations are reflexive, but all reflexive relations are not identity. Suppose elements have 3 elements, then identity relation will have only 3 elements. Suppose A is 3 elements, 1, 2, 3. Identity relation is 1, 1, 2, 2, 3, 3. But for the reflexive relation, besides 1, 1, 2, 2, 3, 3, it may have another elements of the ordered pair A cross A. This is the difference. Okay, thank you. We will discuss other types of relation in our next video.